Open the April 29th meeting of the Wakefield Conservation Commission, and we'll take roll call. Silvana?
Yes, I'm here.
Yes. I know Peter is not here. Ken?
Here.
Teresa?
Here.
Jimmy?
Yes.
And Frank?
I'm here.
And I am here. I see Rebecca. I see Judy. I see a phone number. It might be Elaine on a phone. And let's see. And we do have Kate from Offshoots. So the only thing on the agenda tonight is a presentation and discussion of the bioretention systems from Offshoots Inc. And we have Kate Kennan here to give us a little education.
Sure. Do you guys want
Rebecca,
me to
you got
jump?
anything? Rebecca, you got anything you want to lead off with or anything, or? Just
No,
like
other than thank you very much for doing this. I'm very excited to hear about the topic, and I think that it's very valuable for us right now, and hopefully we learn a lot and it becomes a little bit more familiar. So I'm very excited for this. Thank you.
Sure, happy to.
All right,
Okay,
Kate.
great. So I'm going to share my screen so you can all see my slides. And let's see. Okay, can everyone see my slides okay?
Got it.
All right, let me just make this full screen. Okay, that looks okay to everyone?
Yes.
Okay, so thanks again to the commission for inviting me. So I titled this Green Up for Cleanup. One of the things I'll talk about today is that there are just so many opportunities to use planting and planted systems for water quality. And it's something that I've been spending the past 15 years basically researching and looking at the topic, because everything from what you can do actually in the stream or the water bank itself to a new constructed wetland, to an idea of a floating wetland, to an idea of, you know, some sort of stormwater filter directly along the road. There's so much that the planted system can do. But the devil is in the details, and the challenge is a lot of people also do them incorrectly, and they can actually contribute pollution actually to the water column without realizing it. So I thought I'd sort of give a 101 talk, and I thought I'd start by just telling you sort of my background so you can see where I'm coming at this from. So I grew up on a nursery garden center in central Massachusetts called Pleasant View Nursery. My parents still have it. It's out in Paxton, Mass. And what drove me nuts is that how consumptive the landscape industry was, right? So much water, fertilizer, we all know the story, herbicides, pesticide use. The green industry didn't seem very green to me, you know? And I saw this sort of model of traditional landscape that we plant something for it to aesthetically look pretty. And the idea is we keep pruning it and manicuring it to basically keep it looking the same, meaning it's almost like acts like a sculpture. But the idea about landscape is it's supposed to grow and change over time. And people aren't really used to that. And so there's this sort of traditional model of landscaping that we keep putting in all these inputs to create an aesthetic thing. And what I was excited about doing was this idea about putting in an input and then getting something out of it. So creating what I call a productive landscape. And that's really what I think bioretention systems and green infrastructure, green stormwater infrastructure, as people call GSI is, you know, this idea of what can you put into it. And so, Offshoots is sort of a spin-off of originally kind of growing up in this environment. I got 2 degrees in landscape architecture, and Offshoots is located in Charlestown. We have 17 people. We're a landscape architecture practice, but we also do installation because we try to test new ideas in sustainable landscaping. And then we are about to take over my parents' garden center to become a new resource for if you wanted to plant, say, I don't know, a ground cover or pollinator meadow instead of your lawn, right? The idea is that we're teaching retail about these productive landscape ideas. And so the idea is about at the end, the center of our circle is this new normal for productive landscapes, and that's all about research. And so I do a lot of research, and it all really started, and how this is getting to bioretention is this was my very first site when I started Offshoots. It's down in the town of Barnstable. It was a gas station site, and it was contaminated with petroleum and lead and a bunch of other things. And I knew about this technology called phytoremediation, where say you have a spill of gasoline or lead or something, that you could actually plant a species to help clean it up. So whether it be switchgrass for petroleum or getting down into the subsurface with hybrid poplar, it's this idea that you use plants to continually clean up. And then what I got really excited about is how can we take that literature from peer-reviewed science that's about remediation and apply that to current landscaping so that we're actually cleaning up these landscapes while they're getting polluted, right? And so, and then, you know, how does this relate to the design? And some of these systems are temporary and some of them are not. And so I went to the Harvard Graduate School Design and I started teaching there with Neil Kirkwood, who's pictured here. We started teaching research seminars on phytoremediation and this idea of how could we use plants to clean up sites. And we taught research seminars there for 4 years. And this was that gas station site that I just showed you. It ended up being a cleanup project. And the result of that was a book that we wrote on phyto. So this is, I think, why Rebecca called me. She had started reading some of this book and then realized that maybe we were right here in Charlestown. So Neil and I wrote this book on phytoremediation, and it sort of is a reference that I think a lot of the design community uses to think about how plants and green infrastructure can clean up soils, air, water. So I'm going to take today to do a really brief excerpt of specifically how this can apply to stormwater management and bioretention, which I think is kind of what Rebecca had wanted to focus on, because there's lots of kind of subsets of this we could focus on. But, you know, of course, you're seeing lots of development sites where it might, you know, originally be a natural system or an area that's and of course, I know that you all have a baseline knowledge being on the Conservation Commission. So I'm not going to, you know, cover real basics, but we all know that like this is going to create a lot more dirty stormwater runoff than the green area on the side. We're not soaking it up. So we have a quantity problem because we're generating more runoff, obviously, in terms of quantity that we need to store that quantity, with the idea being that when we develop a site, the water runs off much more quickly, and we need to kind of spread that out over a longer period of time. So the first thing that bioretention and green infrastructure does is it takes that quantity and actually contains it, and then slowly, right? But the more interesting thing that we're interested in is this idea of quality, right? Is that gray infrastructure shown on the left, you know, where you take catch basins, you put it into pipes, you direct discharge it into maybe some sort of detention facility, and then it goes out. But the idea is if we use a green system, we could actually clean up that water as it passes through the system. So where I really start to think about this, especially when it hits the ground with conservation commissions, is a lot of the pollution, of course, if you have a light industrial site or you have a landfill, which I did look up, it looked like Wakefield has one uncapped landfill that's near a lake, I noticed, or near a water body, one old unlined landfill. But it's that you have on the roads and the parking lots is really where so much of the pollution comes from, right? Salt and de-icing chemicals, obviously from the roadways, road and car debris, the actual brake pads themselves and the tires themselves put out asbestos, they put out a lot of heavy metals. So there's stuff that happens there. Emissions, as we know, we're creating particulate matter that then falls down into the areas around the roadway that then gets washed into the water. Corridor control, meaning herbicides, weeds, and insects. And of course, not just what we did now, but what we did historically. So say, for example, we sprayed for gypsy moth, you know, back with arsenic, and many railway corridors and road corridors are laden with arsenic, and arsenic sits there for 100 years and it's carcinogenic. It causes cancer, and it's in a lot of places around us. So we know arsenic can be a real challenge, and it's not regulated in the same way that lead is. Road and car debris, like I talked about, and then the lawn and landscape care industry, like we're talking about, nutrients is the big piece of that, right? Pet waste, we all know, and then the nutrients put in phosphorus and nitrogen that create algae blooms. So, you know, there's all of these sort of systems of green infrastructure, green stormwater infrastructure that we can start to add, whether it be for air pollution, specifically looking at airflow buffers and certain kinds of plants that have sticky or waxier leaves that take up more particulates than others, whether it be surface flow wetlands or phytoirrigation or these degradation hedges. So what I thought I would do is just show you a couple kind of case studies and ideas behind a few of these systems, not like go into everything, but just pick a couple. And I tend to kind of go fast. So if I please, this is super informal. So feel free to jump in and stop me, okay, at any point and ask questions. So, and the other thing too, I don't know if I mentioned, I did teach at Harvard, and now I'm on the full-time faculty at Northeastern. So I teach this sort of stuff daily. So, anyways, why does the plant work in the system, right? Back to 8th grade biology, right? Photosynthesis, the plant takes energy from the sun and it spreads it down into the root system of the plant, where the plant actually can release literally up to 50% of its photosynthetic product as a form of sugars and phytochemicals that create this explosion of microbes in the rhizosphere of the plant. And so the microbes in the rhizosphere are doing a lot. They are coming and they're actually working on contaminants in the soil. They can break down contaminants in the soil. They can do so much for the plant in that they help the plant absorb nutrients, but they're also doing a lot in the soil chemistry. So plant gives a lot of sugar and phytochemicals and what we call it the rhizosphere. Basically, the area in the soil around the plant roots has at least 100 to 1,000 times more microbes than in regular soil alone. So the plant does a lot in the system. And certain plants, have a certain microbial association that's different than other plants, depending on what their contaminant, what their phytochemicals are that they release. And then also plants are an incredible transporter of water. So right through transpiration, they come up and they need water for photosynthesis, but they actually release a lot of that into the air through transpiration, obviously cooling for urban heat island effect. We know that our cities are much hotter than our suburban or urban or rural areas. So having more street trees in the city releases water, cools the air. We know that. And so one of the statistics I love to tell people from one of my scientists from our book told me that trees in North America move more water than all the rivers combined in North America annually, because it's all through transpiration. They basically suck up all this water from the root zone and transpire it into the air. And so they're doing a lot in that process, right? And so there's so much that the plant can do in these systems. And so how does the plant work, right? The first thing we have to know is the thing we're trying to treat in bioretention, right? Is it an organic contaminant or is it an inorganic contaminant? And this is like the basis of everything. And a lot of people don't really understand kind of like what the difference is between an organic and an inorganic contaminant and why we're doing bioretention, what we're actually trying to treat, okay? So an organic contaminant is something that is a compound, right? And we're talking, there's obviously biological contaminants too, and that sort of thing, but this is sort of the basis of it because the biology feeds off these things. So organic contaminants tends to be a compound, carbon, oxygen, nitrogen, things that are link all together, like petroleum, like chlorinated solvents. It can be broken down into smaller parts, often no longer harmful when they get broken down, okay? Inorganic contaminants are something on the periodic table. You cannot break them down into smaller parts, right? Again, now we're at 8th grade chemistry, or maybe it's, I don't know, maybe even less than that, right? It's at its elemental form, okay? So things like arsenic, cadmium, zinc, those are things that we see all the time from roadway contamination, lots of heavy metals, lead, that sort of thing. You can't break it down into smaller parts. So the way the plant works, or even in green infrastructure systems, what we're trying to do in an organic contaminant is we're trying to degrade it. So the idea is you're going to break it down so it's no longer harmful, right? And the plant would break it down into smaller parts, metabolites that are no longer harmful. An inorganic contaminant, the idea would be either you get a plant that can suck it into, say, its leaves, and then you would have to cut the plant down and like bring it somewhere else to harvest it. Or either you're just trying to extract that contaminant. Say if you had dirty water coming in, you would extract it and you would stabilize it in the soil. You wouldn't necessarily get it into the plant, but the idea is that you're not necessarily trying to break it down because you can't, but you're trying to extract it either from the water column or extract it into the plant, and then you would cut that plant down and bring it somewhere else. So that's the whole major difference. So it's two completely different mechanisms. So if you're an organic contaminant like petroleum, or like many of you might be aware of like perchlorate, which is a old dry cleaning solvent, or TCE, trichloroethylene, they're things that you see a lot with contamination around light industry or old dry cleaners. There's a lot of it in Melrose, actually. If you look up the sites, there's one right behind my house, actually, literally, of TCE. And people don't realize that. They don't realize it's underneath the surface because it's down in the groundwater, and it moves quickly. But what you can do with the plant, if the root zone is deep enough, because sometimes TCE is 100 feet below the surface, the plant's not going to get there. But if your root zone can get there, which is maximum 20 feet for a taproot species, which there's not that many taproot species, we can actually get degradation in the soil. And we call this rhizo degradation when it's in the root zone, where, like I told you, the sugars come down, the microbes explode. You actually get breaking down of the petroleum or the TCE. Phytodegradation, where the plant sucks it up and the endophytes in the leaves actually break it down. Or there's a couple other ones too, but that's the whole idea of organic. Okay, so we can do really amazing things with that. And that's what to be completely honest, a lot of the industry doesn't know. Even my neighbor is a LSP, and I'm thinking you guys probably know what LSPs are, but right, licensed site professionals that are ecological consultants. He says, you know, he never sees any phytoremediation projects where we do these things. It's not that the technology is disproven. It's that, you know, environmental scientists, a lot of the environmental engineers that are out there don't know how to grow plants, number one. And number two, it has a very long lead time, right? People don't want to wait for sites to clean up. So that's one of the reasons we don't see it a lot. And it's very plant and contaminant specific, and only some things work well and a lot of things don't. So it's complicated. So separately from that, these inorganic contaminants, okay, something that's on the periodic table, and the ones that we typically see out on sites in the landscape are nutrients, nitrogen, and phosphorus. So you're like, oh, wait, those sound like organic because it's something like a plant needs, but it's not. You can't break it down into smaller parts, right? So it's actually an inorganic contaminant, nitrogen and phosphorus. And that's obviously a really big thing we deal with on Conservation Commission level, right? Is because we don't want these fluxes of phosphorus getting into our lakes that have a really big impact on freshwater quality because you have algae blooms from the phosphorus. So there's also all of these heavy metals that are in dark purple that we see, lead and chromium and all these things, arsenic, selenium, and then radionuclides, right? We're not really seeing those around us, luckily, and then salt, right? So these are all kind of the inorganic contaminants that we see. And so if you were going to use a planted system, a phytoremediation system, you would typically try to find a hyperaccumulator for these. This is a plant that takes up a certain contaminant at least 100 times more than another plant. The challenge is that hyperaccumulator plants, they're supposed to do phytoextraction. This is the idea that you plant Indian mustard, say, for arsenic, and it will suck it up 100 times more than another plant. And then you come along with the tractor and you harvest it. And then you harvest that material and you have to bring it off site. So in Boston, you know, or the Boston area, if we planted a phytoextractor of, say, lead or something, and you planted it out, the idea would be you couldn't just let it die to the ground because then it would just return back to the soil. You'd have to harvest that plant and take it away. But the challenge with this method is that they found through the peer-reviewed literature that there was a problem with bioavailability. So even if you could find a hyperaccumulator of, say, chromium or something, say there was this much chromium in the soil, or lead. Lead is a really good one because a lot of us have really lead contaminated sites, right? There's like a lot of lead in the soil, but maybe only 10% of it is bioavailable to the plant because it's so tightly sorbed to the soils, because the organic content in the soils make it so you can't get it into the plant. So with inorganic contaminants, phytoremediation has actually been quite difficult to do. So the better way to do that for green infrastructure, stormwater and these bioretention systems, is to try to sorb, or attract the inorganic contaminant to the soil. So you're trying to run the dirty water through soil that is going to sorb. It's going to act like basically a big sponge to suck those contaminants onto the soil and then pass through and you get clean water. But it's not that the plant doesn't have a role in that. So this is what we call like a, you know, a stormwater filter system where the pollutant might be immobilized in stormwater. You can see here, the organic contaminants are represented by the circles and the inorganic, the square. So the idea is, so say you get a little drip, drop, drip of gasoline and it's on the roadway surface and the circle comes into the system. It actually gets broken down by the microbes in the soil of the plant. Okay, so the more microbes and the more activity that you have, meaning the more different plants you have, the better your system's going to be. So the soil alone isn't going to do great. And then when the inorganic contaminants come in, at some point, if you kept putting in dirty water and there were no plants, the idea is the soil is going to reach a carrying capacity. The sponge is going to be so full that you can't keep cleaning the water out. And so the idea here is that by adding the plants, they continually create renewed binding sites and keep the soil fresh in a way so that you can keep sorbing these contaminants to it. So it's really important to have an active, living, planted community in your bioswale bioretention systems. This is like the key driver. And so there's kind of two things with it. Okay, so I'm on the way to the American Society of Landscape Architects convention in Chicago to speak about phytoremediation. And I walk by this office park and here's a bioretention system. And they had directed all the stormwater from the surrounding roads right into here. And I'm like, where are all the plants? And this whole thing is mulch instead. And what's happening is that mulch is getting washed right down into the system. And very likely the mulch is releasing more nutrients into this thing than likely they were trying to treat for nutrients, because the nitrogen and phosphorus in the water quality column is the thing that creates the algae growth in our lakes and ponds and streams. And then we have eutrophication, no oxygen, you know, the whole system. So we really got to stop nutrients from getting into the system. And this is washing mulch, which is basically nutrients. You know, it's biomass. It's been broken down right into it. And then not only that, you're not creating any binding sites. You're not breaking down any organics. So these systems that are just mulch are not good. So this is just a really quick summary chart that's on our website. It's also in the book, but this is like I talk about, when is there a good opportunity for the plant to actually do a lot of the work in the system, and maybe less potential down here, right, for phytoremediation. So, you know, explosives, radionuclides, persistent organic pollutants, and a lot of these metals, the plant can't actually break it down or work in it, but it doesn't mean that we can't remove those things from water, because actually planted systems in bioretention have been incredible for explosive and even radionuclide through constructed wetlands. But the idea is the plant isn't, you're not getting it into the plant or doing the breakdown with the plant. You're actually just sorbing it to the soil. But it's very important to have the plant in it. But up here, the plant is doing a lot. Okay. So these are groups of contaminants: nutrients, VOCs, meaning volatile organic compounds, and chlorinated solvents. These volatile organic compounds and solvents and petroleum are two of the best case studies of looking at plants on contaminated sites to be able to remediate those over periods of years. You know, it's not going to happen overnight, but they can actually break down those pollutants. And there's lots of really amazing case studies. And even arsenic, nickel, and selenium, we have a lot of really good ones with plants using hyperaccumulators. And a lot of pesticides and atrazine are like really important things that we can break down with plants. Like I said, all of these other things. So I made this little chart as like a cheat sheet, basically, because over here on the left, this is the good opportunity. The ones at the top are the good opportunity for plants to really break it down in the system. And then less time as you go to the left and more time as you go to the right. So, you know, zinc and even lead is one of the worst things. It's going to get, actually arsenic, we can kind of do some extraction, but these take a very long time. You're not going to get them into the plant, but you actually can get it out of the water and at least held in the soil so we can clean up the water before it goes to some other lake or stream. Okay. So I want to talk about this case study really quick. So this is a Cornell Plantations. It's an arboretum, botanic garden up in Ithaca, New York, where I went to school for undergrad. And Toby Wolf, who's an amazing landscape architect, did this beautiful bioswale system, all native plants, right? So It's having other ecological services, pollinator resources. It's beautiful. They have, well, the water comes in off the parking lot. It first goes through a gravel filter and goes into this swale. And then the swale then gets dispersed into this larger retention swale. And the whole reason they did it is they tested the water quality downstream of this, and there was BB Lake, and BB Lake was getting contaminated with nitrogen. So they did this to get the nitrogen out of the water. All of a sudden, so Toby Wolf says, you know what, 2 years into this, we're going to apply for a landscape architecture foundation grant to actually measure the water quality. Like, is this thing actually working? So they measure the water quality on the inlet of the pipe and on the outlet of the pipe. And the water coming out the end of the pipe at the green infrastructure is dirtier than the water going in. And they measure this over 2 years, continually dirtier. Why is the water dirtier? And they realized that they started changing management practices. The Botanic Garden staff was putting down mulch every year. And the mulch that they were sending the water into with the mulch was leaching more nitrogen than was getting taken up by the plants. And the nitrogen was going right in. So actually running these things through mulched systems without plants or even with plants can be worse than if you actually do it another way. So you have to be really careful about management. And this is the problem with green infrastructure. And again, the devil being in the details is people are putting in these standard systems all over the place, and they're using kind of older details. And the newer research that's been coming out over the past 5 or 6 years is you shouldn't have mulch in these systems, right? They need to have either gravel surface or a composted surface that the compost is aged and isn't leaching phosphorus or nitrogen. So they did some management practices. They stopped mulching it. And lo and behold, the system started working great. So it really is, you have to be really careful. This is so beautiful and such a great idea, but you have to be really careful about who's doing the detailing of these things. We have been doing a lot of work, specifically with Department of Conservation and Recreation, and we just recently did a master plan for the Charles River for 16 miles of the coastline for the shoreline vegetation master plan about like, what do we do for habitat resources and for water quality? And also, so we've been doing a lot of work in the Charles River Basin. And one of the reasons we're doing that is because it was a D water quality in 1995 and got up to an A- in 2013. And as some of you may know, right, it's actually swimmable on many days, but then in lots of days, it also has these huge algae blooms. And the algae blooms, it went back down to a B+. And so what happened is they actually removed the CSOs, right, the combined stormwater overflows. When they built Deer Island, 2013, it started going down, and the water started getting cleaner when they started separating out the sewer overflows. But then after that was fixed, it started going down to a B+, and in the B's a lot. And it's mostly because of phosphorus. Okay, so phosphorus is the limiting thing, and we get these algae blooms because there's too much phosphorus going into the Charles River. Okay, so that's why Boston Water and Sewer got sued, and a lot of other people got sued, and they had to start monitoring and cleaning up for phosphorus. And so what we typically see is that, right, where does the phosphorus come from? And we look at commercial parking lots and, you know, kind of freeways, and we look at these kind of things and how much pollutant loading you're getting by acre. And you can start to see TSS, or total suspended solids, which what happens is you want to look at the measurement of solids in the water quality, because the phosphorus, again, and the nitrogen link on or sorb or attach to those sediments. So if you can get the sediment out, a lot of the time you can get at least half of the phosphorus or nitrogen out of the system. So it's really important, obviously, to get the sediment out of the system. And then you also have dissolved phosphorus and dissolved nitrogen in the water column. But if you can at least get out the sediment, we know we're doing a really good job. Okay. So I'm going to show you a project. We had been working with the Mass Department of Transportation down on the Western Ave and River Street bridges down by, this is the Genzyme building. I don't even know if it's Genzyme anymore, but if any of you have ever taken the on-ramp to get on to 90 from Cambridge, right? River Street is here, MIT is kind of down and across, Doubletree is here. And so we were tasked, Mass DOT contacted us because they wanted to not only get the phosphorus out, they wanted to use green infrastructure to take the phosphorus off this bridge through the stormwater and create stormwater infrastructure here. But this site had some contamination on it. So they were wondering, Kate, can you clean up the site and do the phosphorus at the same time? And so we went through this whole process where we looked at phosphorus. Well, where is it coming from? It's coming from the tires, and it gets deposited on the roadways. And what we need to do is we then get contaminated stormwater. When we have a big rain event, it washes that phosphorus off the roadways, and we want to collect that. But the challenge was on this site, there was also a contamination problem with what we call PAH, or petroleum. PAH are petroleum compounds that are very hard to break down. They're circular kind of ring structures that are recalcitrant and very hard to break down. And this site had them because it used to be an old manufactured gas plant. So the city of Boston had old gas lights, right? And the way that they would get that gas is they would burn coal, and the coal would leave a sticky coal tar afterwards, and the gas would get transported to all the gas lights in Boston. So this site was filled with this nasty sticky coal tar. And what could they do? You know, they could ship it off site. It had been there for 100 years, or we could try to clean it up with plants. So the idea here is we've got phosphorus, we've got this contaminated stormwater, we've got not only that, is these petroleum compounds from the coal tar are getting mobilized in the groundwater. So the groundwater is about 10 feet below the surface. And so when it's going towards the Charles, it's smelling like petroleum when the groundwater is emerging and getting into the Charles. The other pollutant we have is emissions, right? We've got trucks and all of these things like throwing on the air brakes as they're trying to get on the on-ramp or trying to ramp up. And so we know we have particulate matter in the air that we know causes issues with asthma. We know that the asthma rates in Boston are much higher along our 93 and the road corridors. And so we know we have really bad particulate matter. So what can the plants do, right? So we create this whole system where we say, okay, the first thing we're going to do is we're going to send the stormwater through these underground tanks. What's going to happen is, and we need to settle the particulates out of the stormwater. So what that means is, that's what a catch basin does, right? Is you send the water into the catch basin, and the water is supposed to sit there and let the solids settle out. All right. And so that's the first thing we did, is we basically made these giant tanks underground, basically these huge catch basins to settle the sediments down. The other thing you have to do is you really have to create depressions, or what we call the forebay, right? It's the first part that you send the water into that lets the water sit and settle out before you send it in the system, because you don't want the sediments in the rest of the system. So every good green stormwater infrastructure system has a forebay. That's what these depressions are kind of showing, to do that. So in this system, what we decided to do is we're gonna settle out the sediments. We are then going to dig out all of this nasty coal tar soil, and we're gonna pile it into mounds. So we create a bioswale that we're gonna move the water through to treat the phosphorus. And then that nasty, like, soil with all the petroleum, we're going to pile into mounds, and then we're going to plant species that are known to break down these particular willows that have certain phytochemicals in them that attract a microbiology that will help break down the coal tar, which we saw in a lot of the studies, that we're going to plant on the mounds. And then we're going to create a bioswale system that we're going to run the stormwater through to treat the phosphorus. Now, mind you, that it wasn't about getting the phosphorus extracted into the plant, and we weren't like looking for specific species to do phosphorus. The idea is all we were trying to do was sorb the phosphorus to the soil. So we wanted a very vigorous planting community that's going to create these binding sites. It didn't really matter what the plants are. And that's a lot of green infrastructure is, trying to do native plants. Of course, things that support pollinators can be better because they're not pushing out others. But so that was more of our objective. And then we created a poplar buffer, or an air pollution buffer of plants with stickier, waxier leaves that we know are shown to take out, to scrub the air for more particulate matter. So it was like this multi-tiered system, right? And then we looked at a ground cover that would help break down that petroleum in the areas where we weren't doing the stormwater management. So we were sending all the water from the bridge into this system. And so that the end of that story is that we did the full 100% construction documents. We were on the docket. We got it permitted with Boston Conservation Commission. And then this parcel was a parcel that Mass DOT was supposed to buy from Harvard. And then Harvard said no. So this, after we had done all the design. So unfortunately, this is not getting built. But it set us up for doing a lot of other work for Mass DOT, which it's really too bad because we were really excited about it being no one wants a dirty site except for our firm. But we started working on the Longfellow Bridge. And so what we did is we were responsible for doing the green stormwater infrastructure on both the Boston side and the Cambridge side. And the same issue here is we're treating for phosphorus. Okay. And I'm assuming that's a big issue in Wakefield as well, is phosphorus.
Yeah.
And was that right?
Yeah.
Yep. And so what we're trying to do is we're trying to treat the phosphorus in these two systems. And the number one thing that we can do, right, is two things. When you have a catch basin as your pre-treatment, make sure they get cleaned out, right? And I'm sure that you probably have all heard this before, but if a big storm comes in and remobilizes all that stuff, it's going to go right into it. So the biggest thing to do is to make sure that there's a great system in town to vacuum those out and get the stuff out of the catch basins, because 50% or more of the pollutants are going to be in that solid. The second thing is a street sweeping program, right? Again, we all know this. If we keep the street clean and we don't have the particulates in there, that keeps it out of the water quality. So those two things are the super low hanging fruit that anyone can do. And then once we've done that, so we started making sure that first of all, there was going to be a structure in place for management of this bridge that was going to do those things. And then the second thing is we created a subsurface constructed wetland. Now this is a little bit of an innovative technology, and this is why I thought I'd talk about it. The water enters subsurface into a gravel treatment cell. The water never comes to the top. You don't see the water. It runs through gravel in the bottom. The plants grow through it, and in the root zone and in the little, the areas between the gravel, we get organic binding sites that the phosphorus again gets cleaned out or rhizo filtered out of the water column before it goes through. The great things about these gravel treatment cells is that there's no mosquitoes, right? And that's what everyone's worried about. And when you create a wetland or stormwater, is it sitting for over 3 days and then you have mosquitoes. So the idea is it runs through and it cleans it out without ever bringing the water to the surface. So we did 2 of these. Anyone can go visit them. They were constructed a couple of years ago. One is what we call the peanut on the Cambridge side. We designed it not very specifically for the plants to have certain phytoremediation capabilities, because we designed the soil structure with more zero valent iron and things in it that would sorb the phosphorus to it. So we were very careful designing the soil matrix. But we designed a plant community that was entirely native to the Boston bioregion. It is all spiky blue and yellow plants. We knew DCR was never going to take care of this thing. We made it so that it would take care of itself. We put in 50 native species, self-seeding. If you go out there now, and I'm going to talk about the difference between this and the one we did on the Boston side. Boston side, I only put in like 15 species. Here I put in over 45. You'd probably go to the Cambridge side and think it looks a little messy and weedy, but it's all native plants and it's functioning. But we tried to make it so that from far away, it would have some aesthetic, it would look maintained. We didn't use a lot of tall things. So anyways, we used a lot of like traditional landscape architecture sort of ideas behind it, but with it all being native and about pollinators. So here's a little animation about how it works. You get to fly into Boston. The way that it works is the water comes in off the Longfellow Bridge into the first sedimentation forebay, right? The water sits there, lets it settle, then it moves under through the gravel into the first cell, and then under and through the gravel into the second cell, goes through a whole bunch of plants, and then goes out to the Charles when it's clean. And so, sorry, let me keep going. Okay, so I don't have We didn't get it photographed last year because a lot of people think it looks like a weedy mess. So I'm showing you the pictures of the other side because this has less plants. We're going to get it photographed this year so people can see the difference. Here's the Boston side. It's the same exact thing. Here's the sedimentation forebay. The water comes in. See how it's super important that the water sits there. And then see, this is the sediment. But the problem is, again, if DOT doesn't come and clean out that sediment, it's going to get remobilized in a big, huge storm. So we're on, unfortunately, the contractor had a 2-year maintenance contract. I've been on DOT because if they don't go and clean the, and this is the biggest issue with anyone trying to implement this stuff. We all know the management isn't more difficult than mowing a lawn or doing weed whacking. It's just that people don't know how to do it, right? You got to keep the trash out of these things and you have to clean the sediment. If you don't clean the sediment, there's no reason to do it because it's just going to get mobilized right into the system. The other thing is if you're going to mulch it, there's no reason to do it. You know, again, and that's the problem with these things. Unless someone is designing it for you, you know, there's a couple pretty incredible design firms in Boston that do more of this than others. The unfortunate problem is that a lot of the civil engineers come in and they say, we know we can do this, but they're using old standard details from like 15 years ago. And that is a problem. And so what do you do as a conservation commission? I don't know, you try to ask the right questions and hope they're doing it the right way. But the truth is usually it's probably going to be better than just a gray infrastructure system, probably. So you hope that you're moving in the right direction. But, you know, the challenge here is really that sediment. And you can see here, so again, what we did here is I only used 4 species or 5 species in the bottom of the basin. And then I did all very, very mixed native species along the edges for pollinators too. This is sort of it last year and people walking around right on Sturrow Drive. And when you get up into it, this is the swamp milkweed that we used as one of the species. And what's so cool about this is the amount of pollinators in there. And, you know, so you're getting why I love these things, right? You've got the juncus, you've got the Asclepias, and, you know, loosestrife is moving in, you know. So I have them right out there watching it. But if you don't have someone watching it, you're going to change the whole plant community. If the loosestrife moves in, is the water quality going to be affected? No, the water quality is probably going to get cleaned up just as much, but you're not going to be, you know, you'll still be supporting the pollinators, but you could push out some of the other things that might have more of a specific relationship with native plants. So, you know, again, how does this apply on a smaller context? I wanted to put in offshoots photos in here, but I didn't have a lot of time. So I just grabbed some for my class. Is, you know, a lot of cities and towns are doing these smaller systems. The biggest key is you need to make sure you have a sedimentation forebay that, again, can get cleaned out with a hard bottom. Because see, if when you do this, see all the sediment in there? You can't clean that out. And it's just going to get remobilized. So when you have a gravel bottom, like the other way that people do it is right here. It's called a gravel filter strip. And if you don't have place for sedimentation forebay, this is a flow in, flow out. So the water comes down here, goes in. And then when it gets full, it goes out. And see all this mulch? Not so good. But anyways, you flow in, you flow out, but it goes through the gravel. And the idea is that the gravel will at least start to filter out some of those sediments before it goes into the system. So this is used when you can't do a sedimentation forebay, basically. But you know, this problem of having these gravel forebays is really a challenge because then they get all of this organic stuff. So you're going to get a lot of phosphorus into those systems unless someone is cleaning it out or doing something with the forebay. So that's sort of the idea with those. And, you know, a lot of times they're multi-cell systems where we just did an experimental project with Boston Water and Sewer where we did 5 schoolyards in Boston. So we built them 2 years ago, looking at all different kinds of green infrastructure. And City of Cambridge, if anyone wants to see very, very effective ones of these, check out the City of Cambridge did, you know, the Alewife constructed wetland. That's all about stormwater cleansing. And then they did all of these installations, which I should have put the pictures up. I take my classes to go see them at Northeastern every year. They did all in the Fresh Pond neighborhood. They did little green infrastructure systems all over the city to try to soak up the stormwater. And they have a management contract through an outside contractor to clean them up and keep the non-natives out and to do the sediment. And so they're doing a good job. Not only do they look beautiful, they're actually cleaning and they're getting taken care of. So it's so hard to put these things on DPW because they don't know how to do them. They don't have the skilled staff to do it. If they had time to train, it would be a different story. But you are seeing this new generation, I'm finding, of DPW foremen and people who've been getting trained in this and they want to learn about it. So it's like, if you can find the person who has the energy to do it, I think it's like, it can happen, right? Guys, Rebecca, can you give me a time frame? I meant to put my phone in front of me and I didn't.
It is 8:15.
Okay, so I don't want to go too long. I wanted to just show you one idea is you can also use, in addition to stormwater, you can also use trees and plants to clean groundwater. And the reason that's important for your folks is that there are tree species like hybrid poplar. Hybrid poplar is a cross between our eastern cottonwood native and some of Populus nigra, which is the European black, the Lombardy poplar, the one that Monet painted and you see everywhere. These plants are phreatophytes. It means they're a living well, basically. They have a taproot that goes down and they can get to 20 feet. Most trees and shrubs only live in the first 2 to 3 feet of soil, okay? Phreatophyte trees have a long taproot that goes down. And there are certain species of these, like hybrid poplar, that can get down into contaminated groundwater and actually cleanse it. And I just wanted to bring this up because if you have petroleum contamination that's within 20 feet, or TCE, trichloroethylene, or perchlorate, especially old dry cleaners, these systems have been shown to work. We call them hydraulic buffers that can clean that stormwater over time. So you're usually looking for plants that have a higher transpiration rate, so meaning they move more water, like I had originally talked about. And so poplar is a big piece of that, okay? And so we use this term, it's called phytohydraulics, with this idea that the plant is sucking up all this water and can literally suck the groundwater into it. And then in the leaves or in the roots, the petroleum or whatever's in that groundwater is getting broken down and actually cleansed. And we don't have to harvest the plant because, like I mentioned, it's an organic pollutant that literally gets broken down. So it's kind of an amazing system. Not many people know much about it. There's a couple of really awesome case studies. I could show you some that I've done around the Boston area, but I just want to show you one really quick one because I did notice again that, nitrogen and phosphorus are our big issues, right? And I noticed that there was an unlined landfill, like I mentioned, in Wakefield it looked like it was behind the Market Street over there. And one of the things is old unlined landfills, they produce a lot of leachate, and the leachate has a lot of nutrients in it, often a lot of salt and whatever obviously was in that landfill. And the leachate, if you collect it in a new landfill, you collect it in a leachate holding pond. And a lot of the time it has ammonia in it. And ammonia is a type of nitrogen, right? Nitrogen goes through a nitrogen cycle into gas and ammonia and nitrate. And so it's literally it's almost like liquid fertilizer in a lot of ways, right? Because plants need nitrogen. And so what you can do is you can actually take that contaminated leachate and water it back onto an unlined landfill where you grow a plant and then clean the leachate. Or you can plant a buffer around the landfill to clean that groundwater, okay? So there's a lot of people doing this. There's a lot of work on unlined landfills, but also on just things that contaminate with nitrogen or phosphorus, where you're cleaning the groundwater by planting these deep-rooted trees, okay? So this is out in Oregon. I went out to see Jason Smeesrod here. He was with CH2M Hill, which is now Jacobs. They did a wastewater treatment facility. They also did this Riverbend landfill in Oregon, where it was generating all this ammonium and nitrogen. They then collected it and watered it onto a field of hybrid poplar. The hybrid poplar they cut down every 12 years. They then chip it to make cardboard, and they get an economic product for the town. It's actually waste. It's not town. It's actually Waste Management, the company Waste Management. Waste Management actually does quite a lot of phytoremediation. So you can also make biofuel out of this. Poplars are used for biofuel, so you can chip it and use it to make heating pellets for homes. There's a really big industry down in North Carolina that takes hog waste and waters it onto fields of poplar, and then they cut it down and guess what they do with the chips? We haven't had enough regulation for biofuel here in the US, but they have in Europe. So it all gets sent to Europe to get. So anyways, but it's kind of interesting. But anyways, all of this basically, nutrients, chlorinated solvents, pesticides, and petroleum, all in water columns that are down in the groundwater, can get treated with these deep-rooted trees. It may take a long time. And again, if the groundwater is below 20 feet, it's not going to work. But you can look at groundwater mapping and know, you can look at mapping and trust to sort of see where the depth of the groundwater, and if it, and some hydrology of soils and stuff are going to be too tight. You're not going to be able to do it. But there's a lot of opportunity there. And so where I get specifically excited for you all to think about is that these are the major generating uses that we start to get groundwater contamination, right? Anything where you have a gas station or auto repair shop, down gradient of that and in your groundwater, I promise you, is either going to have lead or petroleum of some sort, maybe not from when they are or are now, but some sort of historic use, lots of leaky underground storage tanks underneath them, right? And there's so much you can do around the outside. I'm not going to go through specifics. Dry cleaners, down gradient, not good. Same thing. And TCE is carcinogenic, right? We know it, even if it gets into the air and you breathe it, you can have one acute event and you can have fetal deformation when a woman is pregnant. So why can't you put a dry cleaner underneath a residential unit anymore on the first floor? Because it gets into the air. It's called volatile organic compounds. It gets into the air and you have one acute event and you can have fetal deformation. So, you know, TCE is a really big deal and it can get into air quality, and it's actually quite easily cleaned up with hybrid poplar and a lot of plants. So, but again, only if it's above 20 feet in the groundwater. Graveyards and cemeteries, we don't like to think about this, you know? What do we embalm bodies with? It used to be back in the day that they used arsenic to, you know, preserve bodies, and the arsenic is in old graveyards and cemeteries. Arsenic is, again, carcinogenic. If it gets into your water and you're drinking arsenic, really bad, obviously. But there's also formaldehyde, and formaldehyde is carcinogenic if you drink it in water. So what can you put down gradient of where those water areas go into, right? These buffers, these hydraulic buffers of plants that can actually clean it up. And so I think I'll kind of wrap up with that. I think that's enough information. And then we can save for if you guys have any specific questions about anything. You know, I could show you a ton more case studies. This is a waste management site that we are doing out in, or we did already out in Milwaukee, Wisconsin, and or near Milwaukee, Wisconsin, that we did like a whole system of different things to clean up different contaminants. So, but really, like the summary here is that organic contaminants can actually literally be degraded by plants, and it's like a pretty amazing thing that we don't really like think about. And the inorganic contaminants, we're really going to just try to sorb to the soil, and we have to think about what that soil is made out of, and really be thinking about these solids and getting the solid out of the system. And that, like I said, that this chart is online if anyone is interested in it. And I always put up this slide. It's that, you know, as the designer, we think of ourselves as like the center of the world, like bring in all of these other people. Like, you know, if you're a landscape architect, you may even bring in a horticulturist, an ecologist, and a soil scientist, and your civil engineer. And like, I just keep saying to people, you know, so many people don't really know about phytoremediation, and the challenge is that your civil engineer, it's supposed to be in their wheelhouse, or your environmental engineer, but the truth is it's almost its own specialty, and it's very hard to find those people. And I'm not even saying that, you know, we tend to be we're specialists sort of, but I bring on, for Longfellow Bridge, I had not one, but two consultants on my team besides me. So, you know, it's complicated science. It grows. You could have a beaver come in and eat everything, and then all of a sudden the system doesn't function anymore. So there's a lot of risk, but there's also a lot of reward, and obviously a lot of environmental benefit. I mean, who doesn't want to live next to a green site rather than, you know, a different kind of site? So I think that's probably enough. That's my email address if you know, you guys want to email me with any particular questions too, but I'll stop sharing. So okay. There you go. So that was a lot, and I hope that was useful in what you were looking for, Rebecca, because I wasn't exactly sure, but I was like, oh, I'll just kind of move around this topic.
I think it was perfect. I think that is exactly what I was hoping to get through, get a basic idea. And if anyone wants to ask additional questions, maybe. Not sure if they have any
Yeah,
questions.
I have a question.
Sure, Jim.
Does the, is the phosphorus in the water column, like if it was a lake, it's floating in the water column or attaching to the particles in the water column?
Yes,
of the
so
lake?
it's both. It will be and so I've done a lot of work on phosphorus for the Cape Cod Commission. So there's a lot of fresh, usually in salt water the problem is nitrogen, and in fresh water the problem is phosphorus. And so in the lake and everything, you're going to have it in the water column in both a dissolved form that is not attached to the particulate and attached to the particulate as well. So it's
Okay.
in both. So, the challenge is the dissolved stuff is harder to get at, and which is why you got to run it through soil. But the particulates is the easier stuff to get out. So that's why you go for that first. Yeah.
Okay, thank you.
You're welcome.
Hey,
I
Kate,
have
in
a
that
question.
in that picture of the hard bottom forebay, was that like a cobblestone bottom?
Yeah, so we've experimented with different things. The one that we did for, if you got to Longfellow Bridge, we actually used old DPW curbs like they had around, and we laid them flat and butted them up and ran it so it like looked nice. We've done them out of cobble, we've done them out of pavers, we've done them out of, a lot of the time we'll actually do it out of something hard bottomed that is pervious. So it's like a pervious paver that will let the water go through eventually, like slowly,
Right.
but it'll catch all the sediment. So we've tried all different things, but we are fine. In a lot of these sort of best management practices, right? BMPs, where we tend to partner with the same civil engineers all the time who like really know this stuff. There's a couple of them that are, like I said, are better than others. And everyone's changing their BMPs every year, because originally we all did all of them when I first started doing this. And a lot of, I know specifically like Horsley Witten has written a lot of stormwater manuals for the state and different states around the whole country, and does a lot. They've been on the leading edge of sort of, because they started doing all the stuff in the Chesapeake watershed, which is really one of the first ones to really tackle this stuff. Everyone was doing them as gravel, and a lot of them were planted early on too. And now, it's starting to show that really you got to get the sediment out of there somehow, whether it be vacuuming or however you do it. I mean, we're at Longfellow, we're just doing it with shovels and wheelbarrows to get it out. It doesn't have to be perfect. It's just, you got to get the sediment out of there. And remember, you can have pre-treatment through we call it pre-treatment. You have the green infrastructure, and then you have the pre-treatment on the front end. And the pre-treatment can also be a catch basin. Like the water can go into a catch basin, it can settle out, and then the water from there can go into the green infrastructure to try to get the dissolved stuff out of the column.
Right.
But you got to get the sediment out of the system first. And then the catch basin only works if someone comes and actually vacuums them, right? I'm guessing Wakefield has a pretty good program. I've noticed more and more over the past like 5 or 6 years that I feel like I see vacuum trucks around. Certainly in Melrose, I've seen a lot of them. And I don't even know if it's Melrose, but I've seen a lot on the parkways that I know DCR is doing it on the land that they own. And so anyways, because they're responsible for a lot of roadways too, but it's really important cleaning out the catch basins and street sweeping.
Yeah, Wakefield does a street sweeping early spring. They've already done it.
Yep.
At least I think the entire town's done at this point.
Yeah.
And then they do go around at some point with the vac trucks and get the sumps, from the storm drains.
Yep, that's a big deal. And the other thing, I didn't even mention salt, so I want to just talk about salt for 1 second. Salt flows right through all of these systems. There's no green infrastructure system that cleans up salt. And as you know, salt kills plants, right? So what do you do in those circumstances? I mean, we try to lower salt use. That's one big thing, which is very difficult to do in Massachusetts in these cold weather climates. So we're really concerned about safety. But salt flows right through these systems, and it flows right in a fresh water body. So although DOT is really addressing phosphorus right now, I have a feeling that once they get the phosphorus out of control, the next issue is going to be salt. So
Yeah, that's a big problem in Quannapowitt.
So it really is all about management and working with DPWs and stuff to just put down less salt or put it down only when it's needed. I mean, we've all been there, right? When it's there, there's not even a storm and the salt truck is just like the amount that goes down is just
Yeah.
crazy.
Yeah, the pretreatment.
Yeah, it's a lot. There's a lot of it, but it, you know, that's an uphill battle, I think, because human safety is obviously going to trump all of it. So it's a tough one, but it really affects our environmental systems. Like, as you all know, again, it's like, you know, only Phragmites and knotweed thrive in brackish systems where there's salt, where the other natives won't do as well, maybe cattail, but you know, that's why those systems love high nutrient environments, disturbed environments that are salt. And so that we see them on the roadways in those disturbed environments. So
Yeah, sit down.
it's tough.
What is the minimum amount of time that the water has to stay in the forebay to get any kind of cleaning?
That's a really good question. So the retention time, so they're always, you know, and this is a better question for a civil engineer than for me, because there is a calculation around it, because they're always telling us how big our forebay needs to be. And so, you know, it's based on the amount of rain event, because you're trying to capture the 1-inch storm. So Jim,
Yeah.
I wish I could tell you what that number is, but I don't know what it is. I should know, but I don't.
Okay. Because a lot of times you lose the first flush right out of this, so I don't know how much you're saving.
Right. Well, the thing is, right, like we all know, the first flush, you're trying to get that first 1-inch in there, that's going to be the dirty water.
Right.
And then you get that to settle down, but then the water that comes after that is going to be cleaner because you're not you've already washed it out. So, you know, you like, it's as long as you get that first water sort of settling down in, that's what you're looking for.
Okay.
Yeah. But I don't know how long it needs to be retained, but that's a very good question. I'll find out.
Okay. Thank you.
Mm-hmm.
I have a question. First off, thanks, Kate. That was a great presentation. You do have, I'm an LSP, and another member, Ken, is, I think, pretty close to being an LSP. So this kind of hits home to a lot of the stuff that I do.
Yeah.
One question I have is actually more of a question to Rebecca. Rebecca, is the forebay they're designing for the project they're doing at the bottom of the lake, does that meet the requirements here? I don't recall how it's being constructed, but is it a flat bottom, or is it more of that gravel base that is not really the preferred?
So that's what I was thinking the whole time when I was listening, and I don't know off the top of my head. I don't remember what it is. I do know it's not planted. And so, yeah, it's acting as the settling basin. Size, Jim, I think it gets sized according to, it used to be, I can't remember what it was called, like TR55 or something. Those calculations get done by Bill Renault and sizing according to the storm volume and whatnot that they're anticipating coming in. So I think that's how they size that. Now back to the bottom. I don't recall what the bottom is. I don't remember actually thinking that is something that I should be reviewing, but obviously now I think that differently. So I will go back and look at that, and I will let you guys know.
Yeah, I mean, this is, the thing is in really big systems, you know, all the time they do the forebay, right, as riprap. And I mean, if they can make the argument that it's going to hold all this sediment and it's not going to get remobilized somehow, and I don't really know how that argument can be made, but, you know, I could picture an argument that they say, you know, it's going to filter down into the gravel underneath or something. But I mean, the biggest thing is like, what's the sense of the sediment forebay if you're not going to get the sediment out? So.
I mean, yeah, sure. I'm sure. I know the idea is to have it settle so you collect it, but exactly. I don't remember what it is. And I suppose also when you're talking about gravel, they could remove the gravel and put new gravel in.
Well, right. And that's what we were doing for so long. And then we're like, wait, this is a disaster. This is a maintenance disaster to remove all the gravel. That's exactly what we were doing for a long time. And that's what they do at Cornell, actually. They have that gravel filter strip along the edge, and then they let it collect for a year or two, and then they go in and they take the gravel out and then basically put in new gravel.
And for aesthetic purposes, for something like this particular project that we're talking about, if you walk the lake, you'll end up seeing it be constructed. It is collecting a little bit of stormwater. that currently discharged untreated right directly into the lake. And now it's going to be running through this a system of this, kind of how this whole thing gets started, where it does have the deep sump catch basins, and then it goes to the sediment forebay, and then it discharges into like this vegetated basin, of which I ended up picking all the stuff, and I really want to send it to you to see what you think. But and then eventually we'll get discharged out into the lake. So that's sort of how this whole thing happened. I was thinking that perhaps because we did try to make it aesthetically pleasing, where again, many people are walking along the
Right
lake,
there.
and it is right in the center of town, that maybe even the gravel wouldn't be such a bad idea. However, we just have to ensure that as part of the maintenance plan, it gets changed. Where if we did a flat bottom, maybe some would find that unsightly if it were, you know, the brownish mucky muck. Something to think of. I mean, if they're relatively equal, but one is more maintenance. So I guess we'll probably talk to the town engineer. First, I'm gonna have to review. I don't remember what it was, but good thoughts.
Hey, Kate, thank you. I have a question. Have you seen the bioretention area on the other side of Lake Quannapowitt, closer to
Where is?
restaurant on the a little the other side, where you go into 128?
Yeah.
It's by and I'm just wondering how well that works. That's been around for a couple of years now.
Yeah, I have not seen that one. No.
I think it's by the sand area. I haven't seen
Is
it.
it?
It's right
Yeah.
next to the sand. Yes.
I'll check it out when I go.
Whatever. Yeah, park. Yes, it's right there.
I will tell you, I've seen the one, so I probably shouldn't be saying this publicly, especially when something's being recorded, but I think someone in Melrose, either in DPW or someone, had a really great idea to try some of these flow in, flow out systems, like on a few streets behind me as like little trials. I don't know who did them, but like the idea is so laudable, right? It's so awesome that people like want to do these things, but so much of the detailing in them is a really big mess. And I'm surprised. You know, and then again, I haven't seen them managed, and now they're all just full of weeds, and they're always full of trash, and they made them so deep that people fall into them from the sidewalk, and they're like, they actually seem a little dangerous. There's no forebay. They, you know, get full of sediment. There's just a lot of issues. So, you know, like that's the whole thing. It's like, yeah, let's do it, but like you got to have the plan, right? You got to have the plan for the management on the back end is the number one thing. And then once you have the management, it's just, you know, making sure the details are actually right. So,
And even that it gets implemented is the way it's designed, because Teresa, for the one that you are talking about, from what I understand, I wasn't around when this went through, and I haven't actually seen it, nor have I even looked at the file. So I don't, it's just one conversation. From what I understand, that there were native plants that were selected to be planted, and when it came time to actually install them,
subbed in everything.
They weren't at Lowe's, you know what I mean? So they did something, and I believe and you're right, the intention is certainly good. It's just that, you know, if this was supposed to be like a red cardinal flower, and instead they picked a red rose or something, it may not have really the same effect, I guess.
Yeah. And it probably does on water quality, like we were saying, Rebecca, right? It's like, that's what we're finding with these non-native species. They can do a lot for water quality, but you're not getting those other ecosystem services that we all want. So,
right. So I'm not sure about, I just haven't seen it, but I think I remember that was,
you know, one other detail I should bring up to this group, just because you're reviewing so many drawings, is another old detail in bioretention, in addition to these are the things that if you see these on the drawing, you know that they don't really know what they're doing. The mulch layer is number one. The number two is when they put in geotextile fabric between the bioretention soil and the gravel in the bottom. Say if it's like has an under drain system, or it has a drain in it, and anyone's wrapping them in geotextile. It's a very old detail, because New Hampshire Stormwater Center, through all their testing, showed how it gets clogged, the system over time, and then the water doesn't get through it. And so all the newer details have gradated stone, right? So you go from a soil to then like a pea stone, which keeps the soil out of the bigger stone down below, and you don't do the filter fabric. So if you start to see filter fabric around pipes, it's a very good key that they're using an old detail. So
Actually, can I ask a question in regard to the
Yeah.
mulch? Because I was thinking about that, because I do believe that we had a conversation about mulch in regard to these recent retention areas.
yeah,
So I remember talking about it a little bit with the town engineer, and the thought was, if you put in all of these native species, like we have a whole host of different plants that we're going to put in, how do you prevent weeds from coming in other than hand pulling? Or is hand pulling really the only thing we're talking about here?
no, well, that we don't do any pulling. So, so the thing for me is you do green mulch, and I know it's a different way to plant. So what we do is we put in 1 gallon plants or whatever at 18 or 24 inches on center.
Yeah.
And we put in little plugs in between, or in the case of Longfellow Bridge, I put seed all between it. So the idea is you vegetate, you basically don't keep area for weeds to grow. And then when the weeds do grow, you cut, not hand pull, so that you don't disturb the soil. And then you have the
That makes
seed
sense.
germination.
Okay.
So it's very important. When we did a Longfellow Bridge, like I saw a bunch of invasives coming in there,
Yeah.
we cut. And especially
Okay.
the annual invasives, like say garlic mustard, or like smartweed is a big one, that it's a native weed, but it's a weed and people get all like crazy about it. You have to cut. And like, you can spot treat a little with herbicide if you're not near a resource that you're worried about. But you want to cut, and then, that's a way better thing. But I call it green mulch. We're trying to just vegetate that surface. So I put in fast growing cover crop right away. So like we do like an annual grass, and you can do like annual ryegrass for cool season, so it'll still sprout in December, or you can do oats, if it's later in a warm season, or you can do annual ryegrass, but you just want something to cover that ground in between all the plants really fast.
Okay. All right. That's perfect. Thank you very much. That's really helpful. Hadn't thought of that, but that certainly makes sense.
Yeah.
I have a question.
Yeah.
Okay, so these projects that you're working on, do you
Yeah.
work more with towns and cities, or do you work also with the developers that are
Both.
doing both?
Both.
Okay, and what is the success rate that you've seen so far?
Well-
When you are contracted? to do
Yeah.
so?
I mean, again, it really depends on management. So the thing is, how do you define success, right?
Yeah.
Most of the towns or city, Mass DOT, Longfellow Bridge, we're like, we'd like to test the water to see what it's coming in at clean and it going out on the other end. They don't want to test the water because like they're not required to. And what if it isn't working? So the success though, is it native species? Yep. Is it providing ecological services? Are we seeing it in monarch butterflies? Yep. Do we know that it's probably doing a lot more than what is otherwise, My Boston Water and Sewer project that's a partnership with Boston Public Schools that we did 5 public schoolyards. The first 2 years it went in, they looked beautiful. I had janitors really into them. We did this whole training program. New management, the person left, the BWSC, that was the head of the program. They're not getting taken care of,
Is it an economical issue? Is it
Yeah,
budgets
a lot of-
and
Yeah, I think
it's just-
most of it is that like the janitorial staff, what are they doing right now? They're doing COVID cleaning. They're not out like, I mean, it's not a priority, right? And already the schools and everyone is so strapped. And originally the maintenance funding came from Boston Water and Sewer, and now it's supposed to be Boston Public Schools taking it over, and they don't have the resources for it. So to me, success, of course, it's about the details and things, but to me, it's so much about the follow-up, because if these things get filled with trash and they look terrible, no one's ever gonna think they're successful, even if they're cleaning the water. So, and that's the problem with the ones that are right behind my street. I'm like, these things look terrible and they're filled with trash. And like, I drive my stroller into it half the time. So I don't know. I'm like nervous for my daughter to go on that. I'm not a nervous parent. I'm like, well, we should go across the other side of the street when you're on your bike, because it's like a hole in the ground with no fence around it. So, I personally think most of our projects have been successful, but that Boston Water and Sewer project, like if I go out there now, or like if you go to the Cambridge side of the Longfellow Bridge, Like you may think that that's not successful because it looks like weeds to a lot of people. It's all natives. I promise you. I like inventoried 95% of the plants when I was out there. We did transects through it, but it has primrose, you know, moving into it, and primrose looks like a weed, but it's a native weed. So I left it. I didn't plant it, but it's native. So I left it. And I didn't do that on the Boston side. So I actually have a white paper going about perception and what, you know, what people really want versus what they say they want, you know, because it's, everyone wants native, but when it starts to look messy, it's a different story, right?
Mm.
You know, you just said something, Kate, that kind of triggered a thought regarding native and then cool grasses. If somebody starts substituting something that's not native, that shouldn't be in there, it may not even be the right growth zone that they're putting in there. They could be putting stuff in there that just cannot handle the climate.
Yeah, it's true for sure. I mean, the biggest thing about native plants is people like, so you know, I very much consider myself an ecological designer, but do I do 100% native all the time? No, because the problem is our soils that we have in urban environments are not native. You know, they are disturbed, they're compacted, and there's only a certain amount of plants that are actually going to live in there. And in many things, the most ecological thing for me to do is to have something live in there, because I'm going to get way more benefit of that thing cooling the environment and preventing erosion and doing this than if I can get a native plant in there, right? So, you know, so I always take it with a grain of salt. Do I always tend to lean towards native? Yes, first. But if there's a problem I can't get over, meaning like it's a super salt laden, blah, 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 I'm not going to plant Phragmites, but, you know, I might plant something like Rhus aromatica that is actually low grow, that's actually not native to this county. But with climate change, I know we're going to be getting warmer and it's native to the south and species are going to move. So, you know, you just try to like go with what you think is going to be the next thing. So anyways, yeah, I'm not a native only person, but you're very right, Bob. You have to think about where it's from, what it's going to, and what's going to like live in that soil, which is, you know, this stuff takes a long time to learn. I feel very lucky that I grew up in a garden center because by the time I went to college, I already like knew all my plants. So it's like, it takes a very long time to get all the knowledge. So, you know, you just have to pick and choose your battles a little bit. But
I have another question too, is I don't know if you're following things that are going on in Wakefield, but there's two big issues right now. One is the warrior logo for the school, and you probably can't help with that one. But the other big
Elron's
one,
already went through that.
but the other one is the development that's going to be happening at the top of the lake. I don't know if you're.
I'm not familiar with it. No.
So if you've walked the lake, it's the old Converse building there.
Yeah.
They're going to convert that into a multi-building residential development. How many
Okay.
units were planned there? I forget.
400 plus.
Who is it? Is it Avalon or someone like that?
Like 600 units.
Originally, I think they scaled it back to 400, but we haven't seen the project yet.
I see.
Is it Cabot and?
Do you guys know who the developer is?
No, I don't know.
I was just curious.
Yeah, it is
So-
Cabot Forbes. It is.
Cabin
Forbes,
Forbes,
yeah.
right. So, you know, we've looked at that site many times with the previous owner, or maybe still the current owner. And
Yeah.
one of the big issues has been stormwater management, because the water table is just so high. There's not a lot of options. So I'm assuming bioretention is going to be a big part of the plan to mitigate stormwater
Yep.
flowing into
For
the lake.
quantity too. Mhm.
Yeah, and if you're not involved in the project, have you consulted and acted as a consultant for a city or town to maybe look at a plan and
Sure.
opine on it?
Absolutely. You know, I can't do quantity because I'm not a civil engineer, but I'm happy to do it from a landscape phytoremediation perspective. I did used to do that for the town of Barnstable for a long time, actually. It was more on landscape sort of consulting, but happy to do that. And I know people like some other firms that are quite good at this from the civil side too, is like I mentioned, Horsley Witten. They're mission driven, civil and engineering firm that's down. Their main office is in Sandwich, but they have an office in Boston too. But them or Judith Nitch, they're very expensive, but they do a lot of this stuff, you know, so.
I work
really-
closely with Amy Ball over at Horsley Witten on a project we're doing out in Westminster, Mass now. So I know those guys pretty well.
Yeah, they're just because they're writing I mean, they're writing stormwater regulations for the entire Virgin Islands right now. They'd have no zoning, but they're writing stormwater regs, you know, so they definitely are at the forefront of the research going on. So, but yes, but I'm happy to consult if that's helpful.
Yeah, because I think we traditionally look at, wetland, delineation experts to come out, but I think in this
Yes.
case,
Yeah,
like I
well, and
said,
I
I
could
think-
certainly help with the plant community side of it,
Okay.
right? And making sure that, could help with that too.
perfect. Okay.
Yep. Is it hailing out or is it just like
Doing something out
Yeah,
there.
I don't know, but the water is so loud outside my house
Yeah.
right now. I can't figure out if like maybe my gutter broke and it's like, I gotta go out there and see what's going on. Talking about stormwater. Something's going on out there. Anyways. All
Already,
right.
it's raining here.
Well, it's laudable what you all are doing. I always say, I go in front of conservation commissions all the time and there are always these late night meetings. And it's the fact that you're doing extra stuff to educate yourselves and do all this is just amazing to me. I always say, I don't know how I could ever be on a board because it's just, I know how much time it is. So thank you for what you do. A friend of mine asked me to do the Melrose Conservation Commission. I was like, first of all, there's not very much water in Melrose, but I was like, I can't do it, guys. It's a lot of work. I'm like, maybe at some point, maybe when my kids get a little older, but
It is.
it's great
You
what you
guys
guys
do a good
do.
job.
It's
Yeah,
important.
Thank you, Kate.
Thank
Thank
you.
you very
Thank you
much.
so much.
Absolutely. Feel free to get in touch and send me questions. Rebecca has all my contact information. So
Okay.
Yeah, that was
Thank you.
fantastic. Thank you so much. I loved it.
yeah, of course.
Thank you. Very informative.
educational.
Yeah,
Very
Cool.
informative, yeah.
very good.
Awesome. Great.
Mhm.
Thanks everyone.
All right,
All right,
thank
thank
Enjoy the
you.
evening.
Okay,
Good
Appreciate
night.
it.
Bye-bye.
Frank, I have a question for you. Do
Yeah.
you think there's a way where conservation can put, and I could be wrong since I'm new, what's the word that I want to say? Add her as a consultant when they do this big project on the lake? You know what I mean?
Yeah.
Could she be somehow incorporated? Can we put like a recommendation to that development? Like, I don't know, what do? You go to the planning? I'm just trying to say, am I wrong asking?
No,
that?
we can have
No, we
the,
can have- we can
have
have an
them
expert.
pay for a consultant.
Because I think she would be
Yeah.
real. She
I
would be
think
a
that's a
wealth.
great,
of-
I think that's a
Yeah.
great idea. Yeah.
she'd be
loved
a
it.
Wealth. Yeah.
Yeah. Awesome. Yeah, so it's similar to what we did with Oxbow when 200 Quantipout eventually comes around.
Right.
They'll submit the notice of intent, open a public hearing, and then we'll go through the consultant policy and say we're requesting someone to review this. And depending on how much work it is and where it falls,
Right.
get some people to submit proposals, and depending on how much money it is, I think it's
Yeah.
under 10,000, you can just, the commission can just select whoever they'd like.
Yeah.
And so that's similar to what we did for Oxbow for 100 Hemlock. So we would do the same thing, and it doesn't have to fall under a specific category. It's really anything that you need or would like to have reviewed. So we should definitely do that. That'll be a really big project and probably
Yeah,
Yeah, it
controversial.
would definitely, yeah, I would think something conglomerate like that.
We
Yeah.
can
need-
do it for
You
the boat
need an
project.
expert like her.
Right.
Yeah, you need an expert like her to.
Yeah, good question. I think that's true.
Yeah, that's a good question. I'm not sure we could actually tell them to use her as their
No,
consultant.
no, it'd be
Right.
hard.
No, but I mean, but we can make the recommendation, I think if anything, she has a wealth of.
Definitely.
But I think we hire them.
Right.
Yeah, I think she's a direct.
Review.
They're
she's a
our consultant.
They'll be coming, they'll have a landscape plan and all that, and we can ask, to hire a consultant.
Yeah.
To review
Because
it.
one of the things too that perked me when she said about the designing of the archaic systems with the engineer, I was like,
Mm.
that's thought provoking.
Yeah. Yeah.
With the systems. that she even knew that.
Mhm. It's true.
Okay, is that it for the night?
Yeah, I know.
Are we having,
Why? I found this interesting. I loved it.
are we having a meeting next Thursday?
It
Rebecca?
was very good.
Responses?
I thought it was excellent. I actually
Yeah.
learned a lot.
Oh, I loved it
Thank you,
too.
Rebecca. Yeah,
And we have
was
that
good.
book.
Yeah.
So I've ordered that book and we have it in the office if anyone, and I believe,
I have it here.
oh, you have my, oh, no wonder why I couldn't find it.
There's your book.
Yeah. Don't pull out my Post-its.
No, I'm not touching your Post-its.
Before we go, can you guys hear me?
Yes.
Yes.
Yes, Elaine.
Okay, who can make a meeting next Thursday night?
Do we need to have it next Thursday? Is something time sensitive for this?
Well, this is to make up for the meeting that was missed on the 22nd,
Right,
and
but
I
we have
just
one,
need to know,
we have it on the 13th already.
we do, yes. So I guess my question is, do you want to roll everything from the 22nd over to the 13th? Or do you want to make up what was on the 22nd up on the 6th?
Say we roll it.
How many items were on the 22nd?
There were 3 new projects and 100
Oh.
Hemlock Road. There were 4 things, all of which had meat to them.
Yeah, it's
Yeah,
a
you-
lot.
You got 21 days to set up a meeting, right?
I was gonna say that next, which is, I don't remember when they were received.
I
But
think
you have
that's gonna
21
determine
days.
What we do.
And it takes a week. They have to submit it a week before the meeting because we need that much time to put it in the legal notice. So, and I think that the legal notices went in on time. So you can assume that if the meeting was, what was the meeting, the 22nd, then they at least submitted a week before that. So that's 1 week to the meeting and then a second week to now. So the 6th would make the 3rd week. Elaine, is that correct?
Yeah, I think so.
So it
Do we have
kind of
anything
sounds
on
like
the
you might
agenda?
need to do it on the 6th. I'm sorry, Frank, go ahead.
No, that's good. Is there anything on the agenda for the 13th? Why don't we just move the 13th up to the 6th?
That's a great idea.
Well, there'd certainly
I
be
don't-
some
Yeah, but you
continuation.
have received 3 files already, right? And
Yes.
So you have to make 21 days,
Yes,
and you are gonna do that, right?
yes.
We
Okay.
meet the 6th, yeah.
Mhm.
And that's what we should do.
All right, so I'll send out an agenda for Thursday, May 6th.
It's okay with me.
Yeah.
Okay, all right,
I don't know
thank
about
you.
anyone
And then
else.
possibly cancel the 13th because it would be.
If we don't
redundant.
need it, why? you
Well,
know,
so
Well, wait a sec, if you want to, I don't know, it's up to you, I guess. But do you want to finish up that stuff? There's 3 NOIs and 1 RDA.
The NOIs, we're probably gonna extend them, right? So we can go look at the sites.
Yes,
So that gives you a little breathing room, doesn't it?
it does, but they wouldn't be, then you wouldn't be extending them till probably what, the last week in, or yeah, the last week in May. So you'd have a meeting, you'd have 3 weeks instead of 2 weeks between meetings. Not unheard of, but
Yeah.
there you go.
Could work.
Okay.
Why not? Is that all right?
Okay, so it's the 6th,
but do
it's
we
the
have four-
6th
do we have 4
and the
members with it?
and the 4th, the 1st and the 4th for May, the 1st and the 4th Thursdays for May. Right, we're all good with that?
So
Oh,
the
the
4th Thursday is the Thursday before
Is this-
Memorial Day weekend, right?
You want to do the 1st and the 3rd this month?
you there on the 6th?
So
What are
what
we
would be
doing?
the date on that? Let's see, 1st and 3rd.
May 6th. Start a week from tonight.
Would be the
6th and
first.
20th.
6th and
Yeah.
20th, yeah.
I think that works. That's a good idea.
Yeah, I would rather do that than the Thursday before Memorial Day weekend because I don't know what my availability is going to be.
Good idea.
All right. 6th and 20th works for me.
Okay, good enough. I'll send out the agenda for the 6th tomorrow.
Okay. Everyone's quiet.
Yeah, look at the
9
calendar.
o'clock.
Lot to think about.
Okay, all right, is there anything else?
Any update on the Montrose? The one that's where they cut all the trees and all that?
Oh,
Anything? I've seen some movement. I haven't seen any movement. It looks like they're doing
No.
something. No?
No, I don't
Okay.
have anything yet. We're waiting for this guy. You know, I keep thinking this guy is supposed to subdivide because he's already put in the utilities, thinking that that was going to trigger a notice of intent. But you're right, the project seems to have ground to
yeah.
a stop. I drive by it as well, and there was a lot of activity for a while,
Yeah.
and now it seems to have stopped. And I've stopped by there. Usually I could find him working on the site, and I haven't seen him on the site at all. I usually try and drive by there to see if I can talk to him, but he hasn't been on
No.
the property in a while.
Elaine, I did notice that there is piles of fill in the back of his property.
Yeah, that's what I
And
was noticing
Definitely
too.
looks like it's down in the wetland, if not the
Yep.
floodplain.
Yep.
All right.
So, I mean, and you're saying that he's thinking of subdividing. Well, he's probably trying to make a platform so he can subdivide. But there is looks like there's gotta be maybe 4, I'm saying that good 10-wheeler loads of
Yeah.
material, maybe even trailer loads.
Really? Okay.
Yeah. That's why I think he's doing it. Either he does it late nights or he
Oh,
does
no,
it
I
on
think
days when
it's
nobody's
been
in.
there all winter. I don't think
Oh.
he's done it recently. I think it's been there
Oh,
all
okay.
winter.
Oh,
But
okay.
I mean, it's got to be addressed somehow.
Yeah.
So I guess you have his name and everything, Elaine?
I've got a file.
Maybe you can call him and tell him
Yeah,
that you'd like to talk to
know.
him. Just,
See what's going on. Okay.
Resolve it.
Okay.
Okay.
Yeah, I guess we could knock off approving the 4:15 minutes since we're all here. Take care of that.
We kind of just advertise this as not really a traditional Concom meeting, but more this educational talk. I would
Yeah.
prefer to,
Wait,
yeah.
okay.
I just feel like, you know what I mean? It wasn't going to be a meeting to discuss projects necessarily. I mean, discussing the meeting is no big deal, but, and minutes, I don't know, I feel like kind of technical. I don't know. I mean, I guess you could.
I mean, minutes aren't something we put on the agenda anyways.
I think it's the first thing on every agenda.
Yeah.
Is approval of the
First
previous
item.
minutes.
It's
Is it
the
on there?
first item on the agenda.
Yeah.
It's the first thing we cover, but is it even listed?
What?
Yeah.
Oh, okay, all right, never mind.
Am I crazy? It's the first thing on there,
No,
right?
no, I think you're right, I'm
It is.
You're
tired.
right. You're right.
We did that so that we would purposely approve the minutes every
Yeah.
time we had
Yeah,
a meeting.
that's right.
Yeah.
It was not on this agenda.
Time for me to go.
Oh. And it wasn't on this agenda. You're right.
Yeah.
I mean,
That
I
was just a
prefer to
mistake,
wait.
though.
We'll wait.
Okay.
All right, so anyways, NFL draft is going on right now and we need to see what's
Mhm.
happening.
Eh.
Do I have a motion to adjourn? Is there a second?
Right here.
Okay,
Okay,
Frank,
Yes.
Jimmy,
yes.
Teresa,
Yes.
Ken,
Yes.
Silvana,
Yes.
and I vote to adjourn. All right, talk to everybody
All
next
right.
week.
Good night.
Bye,